Let's look at this simple equation, 2x plus 1 equals 7. In fact, we've already made some shortening of the notation here, because actually what we mean here is 2 times x plus 1 equals 7. And there's one very important point here in mathematical writing, is that the multiply sign I will write in this form, but an x, an unknown quantity, I'll write as this curly x. And this is tradition in mathematics, so we don't get these two things complicated together. So what we have here are two objects, the multiply and the plus, which are called operations. In fact, all operations are made up of multiplying and adding, even taking away, doing minus, or dividing. They can both be thought of as adding and multiplying. Let's see how that works. So if I want to work out 7 minus 4, then instead what I could think of is not 7 minus 4, but 7 plus a negative number. The negative number being minus 4. So all taking away here is all thought of is in terms of addition. The minus 4 here is defined as the number that when I add to 4 equals 0. That's the definition of negative numbers. It's the quantity that when I add it to 4 will give me 0. Okay, so how do we work out this? How is this easier? Well, it doesn't look like it's easier at the moment, but in actual fact, I can rewrite 7 as 3 plus 4, and then I add on my negative 4, and then I realise, well, negative 4 is just the number that cancels out 4. And so the 4 and the negative 4 give me 0. I get 3 plus 0 equals 3. Okay, so that's rather long-winded for just working out 7 minus 4. This is going to be of huge benefit when we don't just use numbers like this, but we use algebraic expressions. Understanding what the negative means is really quite important. So that's how we're looking at negative, or taking away certain numbers. What about dividing? How is dividing related to multiplying? Well, let's think about the division of 3 over 5 divided by 7 over 2. Okay, well, dividing by fractions is always a very tricky thing to do. In fact, we can think of this as multiplication. If I think about any quantity divided by another quantity, what I'm really doing is the same as multiplying. So let's just see how that works. If I have x divided by a quantity, 4, we normally might write that as x over 4. Well, what this actually is x multiplied by 1 over 4. And this 1 over 4 is the equivalent of that negative number. This is called the reciprocal, or the inverse. Or the inverse. And so dividing by a number is exactly the same as multiplying by the reciprocal. Okay, so let's look at our problem again. What happens here? What we need to find out is the reciprocal of 7 over 2. What's 7 over 2? What's the reciprocal of 7 over 2? Well, a reciprocal we had before was 1 over 4. That's defined as the number that when I times it by 4 gives me 1. Not 0, as it was with adding and subtracting, but 1. So I need a number that when I multiply 7 over 2 by it will give me 1. Well, 7 over 2 multiplied by 2 over 7 equals 1. And so 2 over 7 is defined as the reciprocal of 7 over 2. So it should be that dividing by 7 over 2 is exactly equal to multiplying by 2 over 7. And so I can multiply these fractions out now. 6 over 35. So this division by a fraction, which could be quite tricky, we've turned into a multiplication instead. Okay, so using reciprocals is extremely important when we're doing algebraic expressions, and we'll come to that later in this module. Just one thing whilst we're doing fractions, you should be very familiar with fractions, and please do make sure you're familiar with all the types of operations of fractions. And this includes, and just an example, this includes things like, as we just found, multiplying out fractions. This is simply multiplying out the denominators and the numerators. So multiplying out fractions is very important. In a similar way, adding fractions, let's try and add 3/5 and 2/5. If they're over the same denominator, then we can simply add the numerators up. Okay, so you should be very familiar with that. And simplifying fractions, when there is a common factor in the numerator and the denominator, we can simplify that down. Again, we'll be looking at this in terms of algebraic structures as well. And the last thing is, just for negative fractions, if I have -1/9, the negative number here is the number that when added to 1/9 gives me 0. Well, this is exactly the same as -1/9, and that's exactly the same as 1/-9. The negative sign here could be in the numerator or the denominator. It doesn't matter.